Now that we've explained layer 1 and layer 2 design and how we will represent that in a diagram, we'll move on to layer 3. Layer 3 has multiple aspects to it. Layer 3 has multiple aspects to it. We have IP addressing, we also have routing, and those are probably the two main things that we want to represent in a layer 3 diagram. The main part that links into the IP addressing is layer 3 interfaces. Now, if I was actually to expand that out down here, layer 3 interfaces can then be split out, and they can either be port based or virtual, so an SVI or switched virtual interface, and then that's where it ties into a VLAN and links back to the layer 2 stuff. Therefore, if you have a good layer 3 diagram, or I should say, if you have a good layer 2 diagram, then it's easy to map the switched virtual interfaces on top of the VLANs that you have. Now let me draw it out with a very simple example. I'm going to draw two layer 3 handovers from the wide area network. Here's the WAN. Forget about what type of WAN it is, but we have two sites. We have one over here, which is site 1, and another over here, which is site 2. How do we want to illustrate the different parts of layer 3 then, which is what we talked about a second ago? To build a layer 3 diagram up, the first thing that we really need to do is have an IP addressing schema. This should be planned before you even get into doing diagrams really in an IP address management tool, or more often than not, it's probably going to be in a spreadsheet somewhere. But for argument's sake, let's just say that for PE to CE links, where I don't have a PE in here, but let's say this is the PE here, on the WAN, we are using 10.10.10/24, and then we subnet that into /30s. On that basis then, we're going to make this site here 10.10.10.0/30, and this one over here 10.10.10.4/30, and this is a very simplified version of this. We then want to illustrate which devices have the actual IP addresses within those ranges, and we might have some rules like PE equals even number and CE equals odd number, and that might look something like this: 0.5, 0.6, 0.1, 0.2. Now let's develop this a little bit further and say that we have two scenarios where site 1 has a handoff to a router or a layer 3 switch, and the site 2 has a handoff to a layer 2 switch. The reason that I'm providing this example is because this means that the layer 3 demarcation point is here on this site and is here on this site, and that's quite important to illustrate when we're doing network designs. This of course would then have some sort of layer 2 switching infrastructure or layer 3 or whatever further down, but the layer 2 has to have a demarcation point somewhere. One thing that I never illustrated is that I like to denote layer 3 interfaces by making a circle like this. So it's like you're dropping it on an interface, and it's easy to see that where there's a circle, there's a layer 3 interface. And then we can put the IP addresses, you know, this one, this one, this one, and this one next to the interface. Let's move the design on a little bit then and say, let's have 10.11.11.0/30 here, and then .1 and .2. And this is a transit link. So these are transit links being the WAN to LAN handoff. So if this is the WAN router here, and also, you know, these two devices are the WAN routers, this link is a transit link because we've got another layer 3 routing scenario going north and south here. When we look at the other site, where we have a layer 2 switch handing off from the LAN, yes, we might have a layer 3 interface on here, but that's more often than not going to be the default gateway for the site. Or if this was some sort of cut down switch, we might have like static routes. It might be a layer 2 switch with limited static routes and SVI interfaces. So that comes over back to this point here, where we need to make the decision whether we're making it a routed port or we're making it a SVI virtual routed interface. Now, I think that the one on the left hand side, I'll just draw one additional interface in here and say the black VLAN is VLAN 20 and the blue is VLAN 10, like that. And that correlates to interface VLAN 20 and interface VLAN 10 on the router, on the LAN side of the router. What we need to do in between the router and the layer 2 switch, and I'll illustrate it on the site too, is we need to, if we do the same sort of thing, and I won't draw the subnet, the VLAN information in there, that's where you can take some of the information that's defined in this layer 2 diagram and then transpose it onto the layer 3 diagram. But how that might look physically or from a configuration perspective, if we just come down here for a second, if we've got a router that has a layer 3 interface but also a physical interface, we might have different VLANs. That's a trunk port. Okay, up here. And then we have VLAN 20, I said, and then VLAN 10 as virtual interfaces, but on, I suppose, on the same physical. So what do we have here in summary? If I mark it up with a red pen, that might be a bit easier to understand. So we have layer 3 interfaces which are denoted by circles of some kind, and this will be clearer when I go to the Lucidchart diagram. Then in between on the lines we illustrate what the subnet is, here and here. And then somehow we need to illustrate what VLANs come over a single link. So we can do it like this, with, you know, separate links coming from the router to the switch. Or if we wanted to illustrate it like we see at the bottom, with, you know, a single link and two VLANs, but we have, you know, the different SVIs terminated on the layer 3 device. So this is a layer 3 device. And then we would have like another device here, which was layer 2, but you can see that, you know, it's only VLAN 10 and 20 which are actually being plugged down that trunk link. let's move to Lucidchart and create this in a network diagram. I'll now demonstrate building up a layer 3 diagram based on the topology that we showed or drew out on the whiteboard here. So something like that. So again, I like to just use the standard Visio shapes that are included, and I export them from Microsoft Visio and then import them into Lucidchart, which is my preferred diagram tool. Let me just, at the moment anyway, let me just check that the page setup is A3 because it gives more space to actually develop the diagram. Okay, that's better. Alright, so what we want to demonstrate here is have a two-site network. We have a service provider with PE, and if I go to one of my previous diagrams, I can reuse some of the stuff that I've got here. So we have a WAN cloud. Just going to send that to the back so that the lines don't cross over. We have another PE. We also have another couple of routers. Site 1 and 2, site 1 on the left and site 2 on the right. And what we had here was another layer 3 device between the WAN CE and the layer 2 switch at this site. But this site over here, we just had the LAN switch. The next thing that I like to do is put the layer 3 interfaces in. That's not what I wanted to do. I wanted to get the circle shape, which I should be able to find quite easily. And there will be these types of shapes in Microsoft Visio, Lucidchart, whatever it is you want to do. So one thing that I always end up doing is zooming in and out of the different parts of the diagram, because especially when the diagram can get quite busy and there's a lot of information on it, then we need to be able to see what we're doing close up. I'm going to just make this the default style, and now what I'm going to do is just copy this stuff and it's all linked together, so we can just move it like that. But we might just need to make it look good, like so. Okay, so now we have the PE to CE links and the layer 3 interfaces between, and we can talk about color coding and things like that in a little minute. The next thing that I would do is count how many more layer 3 interfaces that I'm going to need. So we need one here, and one here, plus one here as a minimum. Once we know how many layer 3 interfaces we need, even just as a starting point, we can just do Control C, Control V. Let me just copy these. 1, 2, 3, 4, and then move them across like this to the appropriate places in the diagram where the layer 3 interfaces will be. Then we can join them up. Might need to zoom in on that a little bit. Yep, we can join it up like that. that, and that. And now we have the basic structure of the layer 3 diagram in place. And we can start adding the different parts that we drew in, like the IP addresses. If we want to put this PE to CE key or legend somewhere in the diagram, we can do something like that simply by grabbing some text from another diagram rather than finding where to get it from in the left hand side. So let me just sort the alignment here and the size. This might be PE switch 1. PE switch 2. Just by copying and pasting. And you see, once you get the hang of this, you can start reusing stuff that you've already created. So here we are actually talking about a CE router 1. And although there's a separate CE router, this would still be CE router 1, but you might put site 1, CE router 1. Oops. That didn't work. Site 1. And then paste that over here, so it's still CE router 1, but it's might be site 2. So you can see that these are two separate sites. Then we can take this text here and just make this WAN, but obviously this is a very high level, quickly drawn representation. Okay, so if we now start filling in some of the details, so I said 10, 10, 10 for the PE to CE links. Sort of thing I would do here is 10.10.10.0/30, and then we can take some text, Control CV, and then we can start filling in our IP addresses for some of our interfaces. We probably want to align this to the left, and I can't remember what I said is .2, oops, .2, and then this text font is 8 point, so I'm just going to change that here, and then that means I can do Control C, copy and paste, and then that is .1. So that's depicting that the CE WAN interface is 10.10.10.1 and the PE interface is 10.10.10.2. So if you ever need to do a ping test, then this is the type of thing that helps you identify what IP addresses are assigned to which devices. Okay, and then what I'm going to do here is just take the text from that, and the difference that we have on the right hand side is that we have 10.10.10. Well, I'll just type it in because that doesn't seem to be working. 10.10.10.4/30, and then this becomes .5. Bit of lag there. And then this one, because it's the even number, .6. Okay. Now if we zoom out a little bit to restructure things to make look a bit more sensible. The last couple of things that I'll demo here are putting the put in this. Don't know why that's not copying and pasting. Normally does, but I'll just go with the 10.11.11.0/30, and then we need a couple of interface IP addresses. So this one would be .2.2, and the one that's southbound could be .1. And I think now we have the structure of the routed links in place between the WAN and the LAN. The next part then becomes around the thing that I was talking about, where we need to illustrate, the VLANs that are in play if there's switched virtual interfaces. So let's assume that there's switched. We'll represent this in two different ways. On the left hand side, we'll do it as separate interfaces and just show the logical, and on the right hand side we will show another way to represent it. So here what we will have is, let's just say VLAN 10 in the black, and then VLAN 20 in the blue, like we had in the diagram that I drew out. Once we've defined the VLANs that are going over this trunk, we can then create a text box key like this. The objective here is really to match up the VLANs with the virtual interfaces using color coding. Okay, so let's justify the text to the left hand side, and what we're going to do is match up VLAN 10 and call it VLAN interface 10, and then maybe say that it's 10.200.10.1. Then we can copy that, make it blue. Whoops, never meant to do that. Highlight the text. Highlight the text and make that blue. Call it VLAN 20. And then change the octet, perhaps. So what do we have here then? We have a VLAN schema tied to the VLAN interfaces, which are defined in the layer 3 default gateways that are associated. So VLAN 20 has 10.200.20.1, VLAN 10 has 10.200.10.1. And another way that we can do this is if we wanted to go for a pure logical representation. If I demonstrate this on site too, we can do something like this, which is fine for a couple of VLANs, but if you have multiple VLANs, let's say we have 10 VLANs going down here, it's easy to add, for example, VLAN 30 here, and then add VLAN 30 here like that, and we just change the 30 like that, and then VLAN 30, and we might change it to a different colour, for example. Let's just make it red for danger, because we're making a new VLAN, and tie it together like this. If this, for example, is blue, I meant to do fill, so if we fill this blue and then make this line blue, then we can easily identify that that is VLAN 20 if we had a VLAN table somewhere, but it's not too scalable. What I mean by that is if we fill the other one with black, like so, and then we still had a VLAN key somewhere over here, we could represent it like this, or we could represent it like this, which would then tie, if I delete that one and bring this one over here, you could then build up your VLAN key like that, or VLAN to layer 3 SVI key like that, but it's, in my opinion, it's a bit more difficult to track. So let's zoom out. We've got the WAN, and then we've got the PE to CE subnets, the 10.10.10, .1, .2, and .5 and .6, and then we have a handoff internal to the LAN, which is 10.11.11, and we've got the .1 and the .2, whatever your convention is. But then once we get into the LAN, that's where it gets interesting. We can now zoom to a bit more of a in-depth look at this in a more realistic diagram. So if we look at the similar diagram that we've looked at in the layer 1 and the layer 2 videos, where we looked at the layer 1 design, the layer 2 design, and you can see these look all very similar, where we have the physicals and the physical infrastructure as to how things actually work together, and then we move to the layer 2, and then we move to the layer 3, which is the next phase, and after that we would talk about like routing design, where we run BGP and things like that. But before we do that, let's look at a IP addressing scheme of this site. Here, just what I've talked about, here we have multiple VRFs in play, which is something that I explained in the whiteboard sketch. So VRF A is denoted by orange, so you can see here that 10.10.00 applies to the orange, 10.20.00 applies to the red VRF or VRFB. And this all ties together when you start looking at other things about, loopbacks in specific VRFs and reserved ranges. So this 10, 30, 40 and 50 will correspond to VRF C, D and E. And you can tie all this together using colour coding, design notes and observations, and if it was a higher or low level design, you would put this picture in the layer 3 section of the document and then probably put a couple of paragraphs around it. But what you really want to do is, without making the diagram too chatty or too cluttered, you want to put enough information in the diagram to allow someone to understand what's going on in the diagram. Our next session will be about how to represent routing protocols at layer 3, and it will look something like the picture that you see on the screen, but we will walk through that in the next video. Thank you very much for your time, and I hope you enjoyed this video on IP addressing and layer 3 network design.